Patty Simpson with Simpson Math. Let's look at square roots. So to take a square root is just to look for a number that when it multiplies together, it gives you the number underneath the radical. I used a lot of words there that I need to explain. So first, let me look at some perfect squares. So let's look at some things that maybe we know already. For instance, we know that 1 squared equals 1, and 2 squared is 4, and 3 squared is 9. So I've written up here all of the first 14 perfect squares. So if I multiply 5 times 5, I get 25. So now what we are going to do is we're going to find the square root of a number. And when I find the square root, I use this symbol to show I'm finding the square root called a radical. So I'm going to put it here over this 36. And when I find the square root of 36, I'm looking for a number that when you multiply it by itself, you get 36. Well, we know that 6 times 6 gives us 36. So the square root of 36 is just equal to 6. We can do that for each one of these perfect squares. The square root of 1, well, what times itself gives me 1? 1 does. So the square root of 1 is equal to 1. The square root of 4, well, 2 times itself gives me 4. So the square root of 4 is 2. Each one of these I can do exactly that way. The square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. The square root of 36 is 6. The square root of 49 is 7. The square root of 64 is 8. The square root of 81 is 9. The square root of 100 is 10. The square root of 121 is 11. The square root of 144 is 12. You may have those memorized, but this one, 169, I like this little trick here. The 169 is 13 squared, and then if you take those two numbers and turn them around, you've got the square of 14. So the square root of 196 is 14. Those are your first 14 perfect squares. And when I take the square root of it, I just end up with that number that when I multiply it by itself gives me the perfect square. But what happens if I have a number that isn't a perfect square? Say we have something like 2, the square root of 2. What can I multiply by itself to give me 2? It is a number, it's just not a pretty number. So here we've got all these nice whole numbers that are nice and pretty. But the number that I'm going to multiply by itself to get 2 is not pretty. In fact, it's what we call an irrational number. But I can kind of approximate and tell you about how much the number is. I can use my perfect squares to help me. So for instance, I know that the square root of 1 is equal to 1. And I know that my next perfect square is 4. The square root of 4 is equal to 2. The square root of 2 is somewhere between those two numbers. It's between the square root of 1 and the square root of 4. So this square root of 2 is going to be in between 1 and 2. Since 2 is closer to 1 than it is to 4, this answer is going to be closer to 1 than it is to 2. It's about 1.4-ish. I'm just approximating, but it's about 1.4. Let's do the same thing for the square root of 11. There is a number that I can multiply by itself to get to 11. It's just not pretty. So I'm going to approximate. I'm just going to give some sort of approximation. So I'm going to look and see the right below 11 is the square root of 9. And then the next one above it would be the square root of 16, which equals 4. So I know the square root of 11 is somewhere between 3 and 4. Somewhere between there. 11 is closer to 9 than it is to 16. So I know that that square root of 11 is closer to 3 than it is to 4. Approximately 3.3-ish. Somewhere in there. Here's the square root of 70. We're going to do the same thing for it. About how much is it? If I approximate, well, I look at my perfect squares and I see that 70 is in between the square root of 64, which equals 8, and the square root of 81, which is just a fancy way of saying 9. So I know that 70 is somewhere between 8, or the square root of 70 is somewhere in between 8 and 9. Again, 70 is closer to 64, so I know it's closer to 8 than it is to 9, something like 8.4-ish. The square root of 29. Well, for square root of 29, again, I'm going to look to see where's the one below it and where's above it. The perfect square that's closest below it to it is the square root of 25, which is just a fancy way of saying 5. And the square root of 36 is the one that's above it. So the square root of 36 is 6. So I know that the square root of 29 is somewhere between 5 and 6. Maybe something like 5.3. Somewhere in there. So we can approximate our other squares using our perfect squares. Then, when we have perfect squares, we like to simplify them. Just like you do with fractions. You know, when I give you a fraction like 4/8, you simplify that to make it 1/2. It's just a little easier to work with then. We're going to do the same thing then with our square roots. We're going to simplify these square roots. And the way we simplify a square root is we look for a perfect square within the number. And then we break it down based upon that perfect square. So I'm going to look for a perfect square that's a factor of 75. So when I start thinking about it, 4 doesn't go into 75, 9 doesn't go into 75, 16 doesn't go into 75, but 25 goes in there. I could rewrite this square root of 75 as the square root of 25 times 3. This is equal to that. 25 times 3 equals 75. Then we have a rule with square roots that we can separate them. So I can write this as the square root of 25 times the square root of 3. This is equal to that is equal to that. All of those things are equal to one another. Oh, I know what the square root of 25 is. The square root of 25 is just 5. The square root of 3 is a number, it's just not pretty. So I'm going to leave that as the square root of 3. This is the square root in exact form. So here it is in exact form. Earlier, I was finding an approximation. Here I'm leaving it in an exact form. If I wanted to approximate, I could say this is 5 times, well, about how much is the square root of 3? It too will be between the square root of 1 and the square root of 4. So it would be between 1 and 2, closer to the 4, so closer to the 2, so about 1.7. So about 8.5-ish is about how much that is, and so that would be our approximation. Here we've approximated, there it is in an exact form. I want to see if that makes sense. Let's look at the square root of 75. Does 8.5 make sense for it? Well, what's the square root below 75? 64. What's the square root above 75? The square root of 89, 81. Notice that it's between 8 and 9. That's what our approximation was as well. So here we have approximated it. This is in simplified exact form. And the way we got that was we found a perfect square that went into the 75. Let's find and simplify the square root of 45. So if I want to simplify the square root of 45, I'm going to do the same thing where I break it into a perfect square. So 4 doesn't go into 45, but 9 goes into 45. So I'm going to take and rewrite the square root of 45 as 9 times 5. The square root of 9 times 5. Notice that's just equal to 45. Now I can take those two and break them apart. So I have the square root of 9 times the square root of 5. Well, the square root of 9 is a nice pretty number. It comes out nicely so that it's 3, and I'm left with that square root of 5 still being the square root of 5. Here it is in exact form. I'm going to leave it like that for now. Let's do one more where we simplify our square root, our radical here. So I'm going to take and look for a square root that goes nicely in there. 1 doesn't go in, 4 doesn't go in, 9 doesn't go in, 16 doesn't go in, 24 doesn't go in, 36. In fact, man, it's getting hard to find it. So I'm going to try another strategy. I do know that 2 goes into this number because it is even. So I'm just going to try dividing it by 2. 2 times what would give me that 98? Well, 2 goes into 9 4 times with 1 left over. 2 goes into 18 9 times. Oh, I recognize that 49. It's one of my perfect squares. So I could rewrite this. 2 times 49 is equal to 98. I could rewrite that as the square root of 49 times the square root of 2. The square root of 49 is a nice pretty number, but the square root of 2 is an irrational one that I'm going to leave in that exact form. So you can look for, to simplify your radical, you can look for a perfect square that divides into it. If you're having trouble finding the perfect square that goes into it, sometimes just start dividing by something you know goes into it and see if a perfect square doesn't just pop right out at you. So there's a little bit about square roots. Math Made Simple is some math. Thanks for watching.